In this session, we're going to look at some of the things involved in designing a computer program. As we talked about in the last session, there are three things we have to remember when we're setting out to design a program. It has to be reliable. That means it has to work with valid data. It has to be robust. Means it can handle unexpected or incorrect data. And it has to be written in a way that other people will be able to read it and debug it and maintain it. So why do we even plan programs? Why don't we just sit down and start writing code? Well, there are three main reasons why we should. And the bigger the program you're going to write, the more important it is that you do some planning up front. The first reason we should plan is to make sure that the quality and integrity of the program is good. So in terms of quality, we're talking about performance. So we want to make sure that it does what it's supposed to do, that it does it in a safe and secure way, and that it's written in a way that's easy for others to maintain. In terms of integrity, the components that we build into the system should be the right ones to choose. The interface between devices and the system, or people in the system, should go smoothly, and the actions should give the correct results. In terms of our plan, it's also really important to make sure that all the stakeholders are in agreement as to what's going to be done. So the first and most important thing is to get a very, very clear understanding of the task that has to be completed. This should be written down, and everyone should agree to it. That's going to allow you to make a very detailed project management plan. So we have a plan, we can do a risk assessment, we can work out what resources we need, we can schedule those resources. If we don't have a clear understanding of what it is we're doing, it's very difficult to do this. And finally, that plan allows us to see right up front how simple or complex the system is. And if that system has any complexity at all, what it allows us to do is to break it into subtasks or make it a modular design so that each little part can be programmed on its own, tested individually, and then put together as a whole. The other nice thing about this is that after you've written a few programs, you're going to have blocks of code that you can reuse. So if you think it through first, you'll be able to identify areas that you've already written and therefore can reuse. So what's the overall purpose of our software design? Well, first thing is to get us from the idea in a very straightforward way through to our product, which is a program. And to do that, we need to do two things. We have to figure out exactly what the software will do and how it's going to do it. There are generally three levels of software documentation associated with a project. The first is called a Software Requirements Specification, or SRS. The second is called a Software Design Document, or SDD. And the third is called Program Documentation. And we've talked a little bit about that already, which is headers and comments that go right in the code. We'll talk more about that as we start to program. For now, what I want to do is focus on the SRS and the SDD. So the Software Requirements Specification, as the name implies, is going to specify what's required of our program. So one of its main goals is to establish that agreement with our customer, whoever that may be. It's going to give us a preliminary definition of our functionality, and it's going to give us a way to measure or determine whether our program is doing what it's supposed to do. The second level of design document is a design document. And this is where we're going to actually start looking at how. So this one is the what, this one is the how. We're going to establish the structure of the software. So we're going to plan out how we're going to break it into subtasks, and then we're going to describe each of those subtasks and how they work together. So let's take a look at the Software Requirement Specification first. Remember, this was also called SRS. Now, it has two main parts. The first is an overall description of the software, and the second is the specific requirements. So let's look at the overall description first. It starts with a very general description of what this program is going to do. It shows us a block diagram of the main parts of it. It describes what each of those blocks are. It describes who the expected user is, and it defines any limitations or constraints that might impede on the success of our project. The specific requirements are going to define the external interfaces. So this is how the user or external devices are going to interface with our software. And then finally, and probably most importantly, a list of the actual requirements for this program. Now you've seen the acronym SMART before. It stands for specific, measurable, achievable, realistic, and timely. So we know, to summarize that in one word, the key one is, the key two are specific and measurable. And so we need to specify exactly what our software is going to do using SMART statements. Now, what we have here, a Moscow rating, that's a software thing, and the MU stands for must, the S stands for should, the CO stands for could, and the W stands for won't. So once we have our list of requirements, we then say, is this a must in our system? We must accomplish this. Is it something we should accomplish? Something we could accomplish if we have time, or something we definitely will not do in this project? And it's very important, once we have those requirements, to be very specific about what's going to get done and what might get done and what not going to get done. Once a software requirement specification is done, then we would do the software design document. And this one is SDD for short. And it has three parts. It has a description of the system, the details for the design, and a set of test values that allow us to know whether our program is working or not. So let's look at the system description first. It starts with a system overview, and that's going to be very similar to what we had in the requirements document. Then it's going to talk about what kind of a platform we're going to use to develop this application and what kind of a platform we're going to have to execute it. So we might develop on a laptop computer, but we might be designing for execution on a tablet, for example. Then it's also going to identify what the user interfaces are going to look like. In terms of our detailed design, we're going to see now that breakdown of all the subtasks, and that's usually in the form of what's called a hierarchy diagram. And it's going to show the relationship between the main task and all the subtasks, which are the ones where all the work actually gets done. Once we've defined all those subtasks, then we have to describe exactly what's going to happen in each of them. So for each of them, we're going to write a purpose, an input and output. So this is very quick to define what it's going to do and how it's going to interact with the rest of the program. And then the algorithm is where we have to really think, and that's the logic and the order of tasks that each module is going to have to do in order to do its designated task. The test values you've seen before. We want to make sure we're specifying valid test inputs so that we can test for low and high on our acceptable range and somewhere in the middle. And then for robustness, we need to check for those error conditions, so things that are below accepted values or above accepted values, or exceptions.